Darren Llewellyn. Welcome to this segment of MyToolboxTV. Today I want to talk about motor starters. Motor starters are all over a factory. They're used anywhere where there's three-phase motors and also single-phase. And what a motor starter does, it will start and stop an electric motor. It'll also protect it using this bottom section. But we're going to take a closer look at that right now. This is a motor starter as it might look in a control panel. We've got it mounted on one of our training panels here. This motor starter has two main sections. One is the control side, one is the power side. The power side consists of the contacts, which in this particular Allen Bradley model are in the top section up here, and also it involves the overload relay down here. On electrical drawing, they would look like this. These would be the main contacts, and then the L1, L2, and L3, the three-phase power connects up here, goes through the main contacts. After the main contacts, goes through the overload heaters, and then into the three-phase motor. Now, the overload heaters, their job is to protect the motor. They actually are heaters. These heaters get hot depending on the amount of current going through to the motor. If the motor has a mechanical overload, maybe it's a conveyor belt and it's got too much stuff on it, or it's got a bad bearing, or whatever, there's going to be too much current called for by the motor, these heaters will get hot. Different heaters work different ways, but it's going to trigger an overload situation which will open the overload contact on the side. The overload contact is in the control circuit, and this is what the control circuit might look like in a drawing. Now, the control parts of this are the coil. The coil is the main brains of the motor starter, if you will. It's an electromagnet. When you energize it with a proper voltage, becomes electromagnet, and this is what the coil looks like in the circuit. And when it becomes electromagnet, it pulls up and closes the contacts. Also in the control circuit is the overload contact right here. This overload contact is down here on the overload relay, and that's what is triggered when an overload situation is triggered. This contact opens. It's a normally closed contact, normal situations, but with too much current going to the motor, this will open, removing power from the coil. This is what the coil would look like in a circuit. Also in the motor starter, there's an auxiliary contact. That's this right here on the side on this particular model. The auxiliary contact, and this one you can put 4 different modules on it, and I think you can even have 2 contacts per module, but this one, generally when it's labeled 2 and 3 like this, has the main purpose is as a hold-in circuit. The way this works is this. In the motor starter circuit, this is a simple, what's known as a 3-wire circuit. When you have a stop, which is a normally closed switch, and a start, which is a normally open, when you hit the start button, that completes the circuit. Current goes to the motor starter coil. That becomes a magnet and pulls it in and closes the contacts here, and the motor starts. It also closes this auxiliary contact. When the auxiliary contact is closed, it does what we call seals in around the start switch. So when you let go of the start switch, when you take your finger off of the start, the motor starter stays running because you've got this auxiliary contact which is still closed. And it will stay that way until you either hit the stop button, which will shut the whole thing off, or until you have an overload situation, which would also shut the whole thing off. And that's a standard 3-wire control and very common in industry. Now let's disassemble a motor starter so we can look at the individual parts. Let me take this off. This is a General Electric motor starter, which is has all the same parts as the one we looked at earlier, the Allen Bradley, except this is just a little easier to take apart here. If you take out this center pin, which holds on what's known as the armature, that's this metal piece right here. That's what is the movable part of the motor starter. That's what, when the coil becomes a magnet, that's what gets attracted. And here's the coil right here. As you can see, it's a sealed coil. Now, when you're troubleshooting a motor starter, sometimes what might happen is the coil has a problem. The coil gets an open in it, or it burns up or grounds out or something. Coils can be tested with a multimeter by just measuring from the two different contacts to make sure you still have continuity. If you need to know what the resistance value ought to be, manufacturers can give you that information. This is the other part of the armature that forms the magnetic field. And inside here are the contacts. The contacts, this is the moving section of the contacts, and the mating pieces are in here. You can see they're all very nice and clean. This is a new motor starter. The three big contacts are for power. That's where your three-phase would be connected, your 240 or 480 or whatever. This is going to carry a larger amount of current. The smaller contact over here is the auxiliary contact that we talked about, which on the circuit, the auxiliary contact is this one right here. And these are the main contacts here. That would be these bigger ones. The auxiliary contact mating piece is back inside here. So that's the contact part. This big part starts and stops the motor. The auxiliary contact is in the control circuit. Down below, you can see the current path goes through to the heaters down below. These are the devices. I've already got one unscrewed here. I'll take it out. These are the devices that are sensing how much current the motor is drawing. This type is called a bimetallic, and inside here is a device that senses how much heat that this heater is producing. And this is all this is a little tiny heater. When too much current flows, and the motor connects down here, when too much current flows, the heater gets too hot. This device senses too much heat and trips out, opening the overload contact. On this particular model, it's down in here. It's a little harder to get to, so it's kind of sealed up, so we won't be taking that apart. This one also has an adjustment where you can adjust how much current the motor would be allowed to pull. And this is the reset button. If you have a problem on an electric motor, a three-phase motor, and it pulls too much current and it trips out, you have to just figure out what the problem is, clear that problem, and then this reset button resets it. Another problem motor starters can face is dirty main contacts. If your contactor has been in there for a really long time, starting and stopping every time it starts and stops a big motor, there could be a spark. There will be a spark on these contacts. After so much time, these things are silver coated. After so much time, they'll burn holes into the contacts. If it's really a bad problem, the contacts will stop making complete contact. Another problem that can happen sometimes on a motor starter is on the armature. This armature opens and closes like this. If a lot of rust is allowed to build up on this, or sometimes control wires will actually find their way into here and not allow this armature to completely close. It's not making an electrical circuit, but it's making a magnetic circuit. If you hear a motor starter doing a lot of chattering, the chattering sometimes is caused by dirt and rust on these two shiny surfaces, and the magnetic field's not allowed to pull in properly. So oftentimes simply cleaning these surfaces with some emery cloth will fix that problem. Motor starters can be used for years and years without any problem at all. You have to take care of it. You have to make sure that you are being very careful. You're keeping it clean. You're keeping the rust away, the moisture away, and make sure that it's the right motor starter for the right job. Sometimes a motor starter is not properly sized. There are certain ways you have to size a motor starter for a motor. If you size it properly, you'll get years and years of use out of it. Well, thanks for tuning in today to MyToolboxTV. I hope you come back next time. Next episode, we're going to talk about motors. We're going to talk about what connects to the bottom of this motor starter. We're going to discuss three-phase induction motors, the most common motor out there, and how it operates and how to test it. So tune in next time to MyToolboxTV. We'll see you then.